Hello again. Today's lab experiment is on series and parallel circuits. So we're going to go over the basic steps that are involved in the problem, and you'll have other video recordings showing you the procedure that's involved. So in a series circuit, you have the resistors connected one after the other so that the current never branches. And so the total current is equal to the total current going through each resistor. The total voltage, or the total voltage feeding into the series segment of the circuit, is equal to the sum of the individual voltages across the different resistors in this case. So V total is equal to V1 plus V2 plus V3 plus however many the voltages of however many resistors there are. The product of I total times R total is basically taking that equation and putting it in terms of Ohm's law, that I total times R total is equal to I1 R1 plus I2 R2 plus I3 R3 and so on. But it's the same current going through each resistor. And so what you get from that is that the total or equivalent resistance in the circuit, or at least the series segment of the circuit, is the sum of the individual resistances. So R total is equal to R1 plus R2 plus R3, and so on. In parallel circuits, the current does branch out. It splits into different directions, and so the total current is the sum of the currents through each branch. However, the voltage across each branch is the same. And so applying Ohm's law to the I total equation, you get V total over R total is equal to V1 over R1 plus V2 over R2 plus V3 over R3. But again, it's the same voltage across each branch. So it becomes V total times 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So that the total or equivalent resistance in the parallel circuit, or at least the parallel segment of the circuit, follows an inverse sum relationship. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So one of the consequences of this is that the total resistance is actually less than any of the individual resistances that are involved. And that's something that you should be able to observe. So for the procedure, you're going to start by connecting the resistors, or we're going to start by connecting the resistors in series, and you'll see this in the video. So you have 3 resistors, approximate values 1,000 ohms, 1,500 ohms, and 3,300 ohms. We'll measure the actual resistances using the DMM. You're going to connect the resistors in series. The power supply I was having didn't actually go up to 20 volts, so it was more like 5 volts, I think. But it doesn't affect the basic principles you're going to be looking at any. But keep track of what the voltage I set in the video is. Then you're going to measure the current heading into each resistor. So what we're going to do is we're going to insert a digital multimeter into different spots of the circuit, basically in front of each of the resistors, and then measure I total heading back into the negative terminal. So we're going to have 4 different measurements of the current. Now, in theory, they should all be the same. We'll see if that works in practice. Then measure the voltage across each resistor and across the power supply. And that brings us to the procedure in parallel. So again, we're going to repeat the process we had before, only now we're going to set up the circuit so that it splits out 3 ways. And we're going to insert the DMM that we're using as an ammeter in different locations to measure the total going into the parallel segment, measure the individual currents in each segment. So I'll show you how to do those. And then measure the total current coming back out. So the total currents should equal each other, and the sum of the currents through each branch should equal that total current. So that's what you're looking for. And then you're going to measure the voltage across each resistor and the power supply, And those results should be very similar to each other, and you should be able to verify that. So for both cases, you're going to figure out the total resistance from V total divided by I total, so Ohm's law, and then by the equations for each type of circuit. So you'll have measured your individual resistances. What's the total resistance of 3 resistors in series, and what's the total resistance for 3 resistors in parallel? And then do your results agree with the uncertainties? So let's quantify the uncertainties a bit. For the Ohm's law part, for R total is equal to V total divided by R total, the uncertainty in your calculation of the resistance is equal to your calculated value of the total resistance multiplied by the square root of delta V over V squared. So your uncertainty in the voltage divided by your voltage squared, plus your uncertainty in your current divided by the current squared. So basically the fractional uncertainties of your voltage squared plus your fractional uncertainty in the current squared. Now for the series circuit, the uncertainty in your total voltage is equal to the square root of your uncertainty in R1 plus your uncertainty squared plus your uncertainty in R2 squared plus your uncertainty in R3 squared. For the parallel circuit, it's a little bit different. That the uncertainty in R total is equal to your calculated value of R total for the 3 resistors in parallel, multiplied by your fractional uncertainty in R1 squared, plus your fractional uncertainty in R2 squared, plus your fractional uncertainty in R3 squared. Okay, so with that, if you have any questions about any parts of the lab, do not hesitate to raise your hand, or not raise your hand. Do not hesitate to email me and ask you for help. Otherwise, I will see you next time.